following speakers are from the Lockheed Sikorsky organization, Sikorsky division. And the featured speaker is Scot Wrocklage, who's an associate fellow and software architect with over 18 years of experience in the area of embedded systems and flight systems, mission systems. The second speaker will be Alek Taraskewich, also with Sikorsky and with over 7 years of experience in the embedded systems arena. Their talk will be on ACVIP in practice at the Sikorsky Lockheed Martin organization.
All right, thanks, Sean. Welcome, everyone. Scot Wrocklage here, happy to present. Alek, if you want to take us to the next slide. So really, we're walking through how have we started to embed the ACVIP process into our daily work cycle. We've done all sorts of exploratory activities, looking at different analyses, what they could mean to us. And we're showing how now that we've integrated them into our thread, and Alek will walk us through a lot of the more detailed ones that we're using. So again, we'll start with a visualization of our full digital thread, moving through into our analyses. Then we'll talk to the translation tools we're using. Similar to Jason's, we are also using many of the same enablers that have made a lot of this possible for us. And then, like as I said, we'll go into some of the more detailed analyses and some of our forward-looking perspectives with some more enablers for continuous integration at the last slide there. Okay, so looking at the whole process and as how we have embedded it into our life cycle. Bottom left, we have our SysML modeling teams, working on the architecture models within Cameo. We have our software teams primarily doing face data modeling in our in-house tool called AnyCase. And there's nothing special about AnyCase. It's simply the face modeling tool that we choose to use. We have a number of exporters wrapped around it, so that the face model that we work with in our AnyCase tool gets pushed down into Cameo, so we have a complete vision, complete authoritative source of truth down there. But similar to Jason, we're using the SysML to AADL converter as a key enabler to getting it so that we can have a SysML modeling team that doesn't need to know the specifics of AADL, but still can take significant advantage of the AADL analyses that we'd like to get out of the model. So in addition to the AADL translator, we'll also be talking the face to AADL translator, which doesn't work against the Cameo model, instead works against our face model. And Alek will walk us through how those models get merged into a singular AADL model, which we use to produce the analyses of interest, which you can see on the right. The ones on the right are the ones that we are using today or looking at using today. We are not limiting our scope to that longer term. That's just where we're at in terms of where we've integrated it into our processes today. So I think with that, Alek, you want to take that on the next slide?
Yeah, wonderful. Thank you, Scott. So kind of diving more into the details of kind of how we've been experimenting with things and implementing them into our digital thread. We're going to kind of start off with our translation tools. Kind of like Jason talked about earlier and Tyler even earlier, we utilize the SysML AADL bridge tool that Adventium includes in their CAMA base pack. We also use another tool that hasn't been talked about, is the face data model to AADL translator tool. This comes from Carnegie Mellon SEI. So we utilize both of those. And this allows us to kind of generate AADL models from the SysML in the face without having to kind of directly modify the source code and spool up and kind of learn that technology stack. We still understand it, but there's a lot of advantage to kind of using SysML. A lot of people already use it. It's widespread kind of across the organization. So it's kind of a more common platform and, lower learning curve. This also allows us to maintain kind of this single source of truth, right? So our SysML model can live alongside our other models and packages in Cameo, and we don't need to have another content management system to kind of keep our AADL organized. So we have this one source of truth that we can go from. And also kind of getting into the face portion in that generation, it prevents us the need to kind of replicate data that kind of exists in the face data model. And what that really means is if kind of you look at this little diagram right here, is that our face data model already establishes the connection and flow properties within the integration context and integration diagrams. If we wanted to do that in, raw AADL or through the diagram generation, there would be kind of a lot of recreation of, source data that already exists. So really being able to kind of utilize that face data model and generate that connection and flow information is vital, and increases kind of the productivity, and also reduces the chance of kind of human error in kind of developing these connections and flows. As kind of Scott showed earlier, what we do is we first generate, this set from the face data model, and then we generate this second set from the system model using the AADL bridge tool. We do have a little bit, as we would like kind of an automated solution to kind of merge these two, but right now it's currently a manual process, but we are exploring so that the thread can be totally digitally and automated, but we do have this one manual portion where we do have to merge these things. Moving on to the next slide. The ADM, so talking about kind of, processor and memory utilization, I believe Jason talked to this a little bit. We first developed a model that, represents our hardware and software architecture. This is kind of our base level model. We'll be able to use this and refine this over time and, add specific parameters to it as the system, moves further along its maturation process. And we'll also be able to use this for other, analyses, not just, utilization. It's really kind of the backbone of all our analyses. We can use this actually to, virtually test design trade-offs within the subsystem. And kind of going down to this little pictorial down here, this isn't obviously SysML and in Cameo diagram, but it kind of represents kind of the abstract concept of what you can do visually here. As you can see, if we have kind of one version of the architecture and say we want to make a modification, we want to add another software component to a particular partition, you can kind of, easily, and Tyler talked to this earlier, you will define it as your block, you will define your binding, so you combine that software component to the actual hardware component, and then you're kind of off to the races. You don't really need to modify any source code. You can do this directly in Cameo. You can also swap things. So you can see you can swap this software component 4 with software component 2. And you can ensure we see kind of the time and cost savings as, design changes do not require source code modification. And we can kind of run this utilization analysis for, memory and processor to ensure that there's feasibility before ever, writing any source code and modifying it. So we'll know right off the bat, hey, we added this software component or we moved the software component and our utilization has kind of, gone past the supply that's available. We didn't spend the time actually writing the code to do that, modifying the source code. Deploying it to the actual target hardware, we save some time in doing that. You can go right back to the drawing board. Also, this adds kind of a nice little, Cameo allows for the visualization of kind of the system design. Yes, in AADL and OSATE, you can either create the diagrams, then generate the source code, or vice versa. But again, kind of going back to, Cameo and SysML being more commonplace in the organization, kind of doing it in Cameo would be the preferred method, as, various people within the organization might be more familiar with that symbology rather than the symbology that's represented in OSATE. Still talking about kind of subsystem processor memory utilization and analysis. There's a couple different tools that you can use. You can use the native OSATE, SEI latency analysis tool, or you can use the third-party tool that Tyler briefed earlier this morning, the faster utilization that's actually included in the Cameo base pack. And we actually do utilize that tool. We like the kind of flexibility that it offered us in designing these things. The profiles exist in Cameo as well as in AADL, and it kind of allows this nice visual report rather than kind of looking at, spreadsheet or tabular format. It gives us this report that you can highly customize and add to that I will get into on the next slide. Doing this also kind of, replaces kind of the manually calculated methods. If we previously or currently, say we have utilization metrics on, memory and processor, you might put that in a spreadsheet, you might have some macros and functions that kind of compute the utilization based on those raw metric outputs from running the source code. Now, you don't need to kind of manage those spreadsheets. Everything exists in the model, and you have kind of iterations of the model that you can kind of go through over time. So it removes kind of one, another item that requires management. So the KMA tool suite, like I said earlier, kind of offers this analysis report with things like FastR that you can use, and it's highly customizable with this kind of report generator tool that they offer. The great thing about this is out of the box, it works pretty well. As you can kind of see here in this default template, this is what you would get when you kind of run an analysis in the example. You see your supplies, and then you see your demands, and then you see your computed utilization, and this is processor utilization. So what it can be done though is it can be modified, and it can also be post-processed. They allow this very extensive. This is a very simple example, but you can do a lot with this templating system. So over here that we found value in kind of updating the visual representation of the utilization, rather from going to 0 to 1, we updated to a percentage, and we also included the significant digits and kind of the rounding estimation for that. Because obviously, if you look at this, it's saying that utilization is 100%, but it really isn't quite 100%, and you want that kind of level of detail in this. Also, something that we really wanted in terms of a metric that we thought would be interesting is this, core roll-up of the partition. We wanted to get kind of a cumulative utilization across the core of the partition utilization. So we were able to kind of update the template to kind of bring in those values and compute the demand across the core. Moving into kind of subsystem latency analysis. This kind of captures and Jason talked to this earlier, this captures kind of end-to-end timing your latency metrics for, multiple components with your system. And it also allows for this to work with kind of a VxWorks RTOS subsystem. A couple of interesting things about this is that, the AADL annex for FACE, defines that each UOP, your software component is modeled as an AADL thread. And that might be true for many cases, but one limitation that we saw in kind of working through our examples and experimenting is that, subprogram parameters, subprogram being, any sort of kind of, function within the software, and call sequences are not currently supported. So a little bit of a limitation there that, we're still working on kind of figuring out and finding a workaround to maybe implement something as a sub program and get the AADL generated. This is an important analysis. Like I said earlier, we kind of developed this, memory and processor utilization model as kind of the backbone. What we can do with that model is then add kind of these latency parameters on top of it, so we kind of get dual use out of it. It's not kind of a single use model. We just need to properly stereotype, and add any sort of connections or other, SysML components to the system, and then just generate it. And latency, with respect to kind of latency, we want to run this analysis kind of like the virtual integration for processor memory utilization. We want to ensure that any architecture modification with latency impact can be analyzed prior to code modification. It's very expensive to modify the code and then deploy it on the target hardware. If we can do it accurately within the model system, that's going to be our best way to do it. So for example, kind of in this diagram that we have here, we're going to, say you have 2 software components that, and you can do this across any, abstraction level or hardware level, but for the sake of example, say you have two components, you have partition 4 and partition 1, and they have, a common messaging interface where they need to communicate a lot, but they're in different parts of the system. And you want to experiment, and you're seeing a high latency, right? You have the ability to kind of generate your AADL and run this latency analysis, and you determine that there's high latency. Well, you can easily run the experiment just by decoupling this software component from partition 4. You can move it over to partition 1. You can rebind everything. This takes a couple minutes. It's very simple. None of the other properties change. You're literally just moving this around in the system. You generate the AADL, which takes about 30 seconds, and then you run the analysis, which takes about another 30 seconds. So in the matter of 5 minutes, you can understand if moving a software component within the system will output a better latency. And that goes for kind of the memory and processor utilization, or any of these types of utilization. The pure advantage of is kind of moving these blocks around, and kind of the SysML diagrams within Cameo is very easy, and it's very easy to kind of render that AADL using the SysML bridge tool. So we see a huge advantage in maturing this model and being able to run this, because if we ever see an issue or latency in the display of flight data showing up maybe outside of kind of the required or expected latency, we can easily move stuff around before ever touching a piece of source code. Scott, I believe you're going to talk about the Mills MAD security analysis.
Sure. So I mean, another area we've really been exploring, we haven't solidified quite as well as the area is latency and utilization that Alek talked to, is the cyber domain. We've been working very closely with our cyber SMEs on what analyses will make the most sense for us. We've talked significantly about using the Mills analysis within the model, which I'm sure many of you are familiar with. That's really looking at the different security levels and making sure that separations are implemented through those privileged components that are allowed to do that. Also very interesting to us, though, is the MADS analysis, where we're looking at domain separation, and not just for cyber prep, but looking at expanding the different domains potentially that could be isolated, such as, like, for instance, design assurance levels. If we had areas of high DEL information, high integrity data, and then areas of lower, and making sure that within the model that there aren't connections where low integrity data is flowing into high integrity systems and things of that nature, and using a MADS analysis as a way of, to Alek's point, virtual integration prior to going and implementing and finding those issues later in the process.
Okay, thanks, Scott. So also one model where we're still working and exploring is kind of network utilization analysis. Now, before, when we were talking about utilization with respect to processor, memory, and then latency, we were talking about a single system. But we also want to across the various subsystem components that are connected. They could be connected through any interface, really. But in this case, Ethernet. We want to ensure that the kind of bandwidth supplies of the network meet the demands of the message traffic. So same exact thing that we've kind of been reiterating throughout this whole thing. We can use this for virtual integration and ensure that any message interface modifications, say a message size increases by a lot, or there's a particular moment in time where we are adding quite a few messages, we want to make sure that we have the supply for that. So that's all being modeled in Cameo. Once again, the AADL generated, and then the various utilization analysis run against that to determine if we're within those parameters. We're also kind of doing this ongoing effort where we want to model a solution to kind of analyze deterministic in a fixed messaging scheduling system, Ethernet system. And this would essentially be kind of like a schedulability analysis to ensure that, these messages that are supposed to, be sent and received at particular timestamps do meet their deadlines with minimal jitter. So that's something we're actively exploring at this current time as well. Then kind of moving on, kind of a prospective look into kind of the future of this process and how we see it playing out. As we described earlier, we have our face file, we have our SysML model, and those are our sources of truth. We're then going to use our AADL translation tools. We're going to do the model merge. Hopefully at some point that will be an automated rather than manual. But then what we want to do is once our models are refined and we're comfortable with the analyses and the outputs, and we, have customized the reports and tailored them to the way that we want them. We plan to kind of kick these off and automate this whole process through a tool that Aventium Labs has created called the Continuous Virtualization Integration Toolkit. And this kind of expands on our software factory and CI/CD type activities where we don't need to manually generate the AADL merge stuff, bring it in OSATE, run each analysis here. We can all kick that off, even if you still have to press the button to generate the AADL and Cameo. There's still a huge advantage to just being able to run this CVIT server that automatically spools off the analysis and gathers the results for you. Huge time savings in that. Coupled with kind of the use of that CVIT, we plan to use kind of this design space investigator to kind of track model changes and analysis outputs over time. The design space investigator is also used for kind of design trade-off analysis. So we can use that to compare two different versions of the model. So that, again, kind of going back to virtual integration, there's commonly, not one solution to a problem. So we could come up with multiple solutions, run it through this automated system and kind of compare the output data in this design space investigator. But yes, we can also use this to see how kind of parameters in the model change over time as well, being kind of prospective and retrospective. And kind of these arrows just represent kind of the iterative process over this that kind of like as software is iterative over time, the model will iterate over time.
And similar to a software factory or a CI/CD for software, I mean, someone commits code, it breaks the build, the pipeline immediately will reject. Let them know, hey, you have broken the pipeline, something has failed, you need to go and correct it. We can actually see, this is all prospective, but you can start to see similar things, almost what Jason was talking about, where if you're not careful with the stereotypes in the converter, you might produce errors in your AADL analyses. And with that in a continuous pipeline, someone makes a change to the model gets updated, it flows through the continuous process, you get errors in the analyses, and they find that out very quickly, and they can go and repair the data and get that much quicker to the source of the mistake. So I think that was our last slide, right? Alek, we do have a couple of questions I think you might want to tackle. From Bill, as you perform analyses in the AADL model, how are the results made available to the SysML model?
Yeah, so let's see. Oh, wait, you're starting at the bottom here.
Oh, no.
Bill Richardson. There's a couple, yeah. Bill Richardson has two. Also, I'm going to start at the top with Bill Richardson.
So that was from the prior presentation.
Was it?
Bill Lozier is the one we're looking for. Yes.
You could answer the first one too if you want.
Okay, I'm sorry. No, I think I remember Jason answering that quite well. So there's nothing more that I can add to that. But Bill Lozier, as you perform analysis in the AADL model, how are your results made available to the SysML model? This is something, that we've kind of talked about. And, it would be great if we could kind of, go from the AADL model also to this SysML model automatically. Right now that bi-directional capability doesn't exist. So really what you're doing is if you perform the analysis on the AADL model, say you want to check something or feed some data, you get some insight and you want to make modifications to the SysML model, you're going to have to kind of go back and do that manually. They don't really go back.
We do have, Alek, we do have the SysML model reach out to the actual analyses that are generated though in our complete model. I think he's asking more about the results of the analyses. Not that you would change the system out, but our system out, we do have packages that export out to the results files.
Yes, but they're not currently tied together really. They're kind of mutually exclusive.
Sure.
Does that help answer your question, Bill? Maybe I didn't understand it fully.
All right, well, why don't we move on to
Yeah, I'll
the
move
next
on to
one?
Bill. I see.
Yes, Bill may come back later.
Yeah, I see Alex is typing and Jason is typing. So Bill Richardson, can you discuss some of the successes and challenges in merging? Oh, hold on, it's updating real time. So challenges in merging your face data model and Cameo model into one AADL model. Well, the great thing, the success of it is that we don't need to redo that work in creating kind of the connections and flows in raw ADL or in some AADL diagram, right? So you have that face data model, you have all that information in your integration diagrams and integration context. Now you just need to utilize it with that face to AADL translation tool, and that's wonderful. And it is really a copy and paste, and to some extent, actually, you could just do it as kind of like an includes, right? You kind of just includes that as a package, and that works well. But yeah, the big problem is anytime you have some sort of manual intervention to kind of merge these two pieces of source code, you open yourself up to potential human error and not copying these things correctly. And there's also time, right? If you have, 50 different, software components, all with different connections and flows, that's going to take a considerable amount of time to, copy, paste, make sure everything's merged correctly. Being able to kind of merge these things in an automated way would be very advantageous and really is kind of the only manual aspect to our process now. So solving that problem is very important to us. Hope that answers your question, Bill. Moon, face models that exist in dot face, is this information flow to the SysML model? Yes, it actually does. We do have another translation tool. I think that's in one of our beginning slides. Actually, I'm going to go back to it if I can. So yeah, we do have, so our face data model, we have actually two translation tools. We convert it into the .face file, and then we use that converter file to kind of get this AADL kind of connection and flow data model. But also we take this, in the format for this is .acm. That's just kind of the any case raw, XML format. But we do have a tool that actually converts that from any case into, our SysML model. I'll leave this slide up. Oh, now let me go back to the Q&A.
I think we got him.
Did we get him? Okay,
we're
yeah,
done.
Bill, your question
questions.
was answered. Go ahead. I'm sorry, Shalom, if that was
I did
you.
have one question. I think you kind of touched on it as you went through, but this has to do with benefits from taking the SysML ADL base approaches to the modeling. What was the main benefit that you see from these merging across these multiple tools, as opposed to either using them independently or just using SysML on its own?
Yeah, so what we have found is any case is kind of, and maybe Scott has been around any case a little bit longer than I have, so he can speak to the advantages. But for our particular team, we've been using any case longer than we've been using Cameo. So developing the face models in Cameo works for us, and then just writing the quick conversion tool to import that into Cameo is the process. And then also being able to use that same any case face data model, converting it into .face, and then getting, using your face to AADL conversion tool to get the connection and flow data model is great for including that in kind of the hardware architecture model that just kind of, represents all the hardware, software, processor, memory kind of hierarchy definitions. Does that answer your question, Shalom?
Well, would you say is that the advantage that you do get the analyzable results that you would not get from a standard SysML tool environment?
Yeah, I think so. I mean, as of right now, I actually don't know of a tool that could convert a Cameo SysML face data model into a .face file, but I know our in-house AnyCase tool does do that.
Okay, thank you. We're just up to the next speaker time, so thanks very much. I want to thank both Scott and Alex for their presentation, and look forward to continue to work with you as
Thank you for the opportunity.
part of the team. Thank you.
Yeah, thanks everyone. Appreciate it.